Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hi everyone and welcome to another episode of Three Devs and a Maybe. I am Michael Budd and today I am joined as always by Ed Mann. How are you?
Hello, I'm very good. Maybe I should say sometimes, no, I'm not very good, because I realise I just say, yeah, I'm good all the time.
Yeah, just come on one day so you know you're...
But I am genuinely all pretty good, so it's all good. How are you doing, Mixter?
Yeah, not too bad. Not too bad. Busy as always, but yeah, it's just living the dream. So
very, very nice.
Yeah.
I was going to say, have you been keeping up to date with the AWS reInvent stuff that went on last week?
No, but I did see emails and there was something that came through which looked interesting. I can't remember what it was. It was something about Lambdas increased something or other.
Yep. So there was a lot. I was sad enough to watch the keynote live and all that kind of stuff. They put on for development, I've realized they are like the Apple event kind of thing, you know, where they've got the keynotes and they've got all the product launches and stuff, and it's very Apple-like. Yeah. So it's quite exciting, really, and really nerdy. But yeah, one of the ones was the Lambda. So the double increase in memory to double it pretty much. So it was 1.5, now it's 3 gig of memory per Lambda. So when you're running a Lambda, you have 3 gigs worth of memory to play around with, right? Which is great for, intensive memory intensive stuff. Yeah. So it just adds and expands on what you can actually do with a Lambda, which is great. A couple of other things. One thing I really wanted to talk to you about actually was, because I know you, when you did the university course and stuff, you were looking into machine learning and things.
Yes.
And there is a lot of stuff that AWS is doing around that. Yeah. Like the new P3 series just is insane. So that's like a P3 instance type, which compute for compute. And it is insane. Like the amount of GPU power you get out of it, these Tesla Ultra GPU graphics cards, all this craziness. Yeah. But they're doing a lot of work with not only the underlying stuff, like I think it's like Apache MX and TensorFlow and stuff like these for learning algorithms, but they've made a level on top called SageMaker, which is essentially allows you to build these kind of I don't really know how to word them, build these models and stuff to teach and learn them and all that. And then they've got the layer above, which is their application services, which is stuff like they've got Amazon Comprehend, which allows you to parse text and it will do natural language processing. So it'll work out interesting parts of text and people and places and sentiment analysis and all that kind of fun stuff. Okay. And there's other things like Amazon. What was it called? There was one which was to do with Amazon. So it could actually convert speech to text. So it was one thing I was thinking for the podcast particularly was to get show notes out of it. And it's quite a cheap service, I think it will be. It's only out in private, in preview at the moment. But it would be really cool actually maybe to get kind of all of the episodes, run through it and get some show notes out of it so we can actually get some transcripts. So it'd be quite interesting. But there seems to be so much stuff around it. And I definitely recommend if you've got some time, because I know you're very, 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 so much non-busy, so much time, you're a non-busy man, they say.
That's right.
SageMaker looks interesting for machine learning.
Okay. That does sound quite interesting. I know, I can't remember if I mentioned this in the last podcast, but obviously, since you were banging on about, Amazon is so brilliant, everyone should use it. Anyone who doesn't use it is an idiot. Quote, absolute quote. But so I did start looking at it, and I was using S3. I started playing with it and stuff. But I've got one question, and it's a silly question, but as I think you once said, the only stupid question is the question you don't ask, right?
Absolutely, sir.
Right. So I've been looking a lot into the encryption side of things, and the encryption they do out the box and all the rest, and it all looks great. But my big question is at the moment, and it goes back to that kind of cartoon where you've got this big installation with servers inside and people outside with machine guns and all the rest, and then there's just a door open at the back where someone could just walk in and get stuff. And it's you could have all the best software, all the best kind of encryption, but if people can sort of get to it, then it's redundant. But so my question here is, if someone had your username and password to your actual Amazon account, as soon as they get in, they could do pretty much anything, right?
You are correct there, sir. So that becomes the point of like kind of you have to two-factor it. You have to lock accounts down. You have to use good passwords. You have things like KMS, which is the key management service and stuff. So there's a lot of things between like data at rest and data in transit. In transit, you use like TLS and things like that to encrypt it all through. So, going from, client to client or, between servers and whatnot. And then you have at rest where you can encrypt it using like things like KMS, which will encrypt like, say, the EBS volumes and all of the data itself. And then you have the keys available. You only have the key available and unlock it based on, your user credentials and stuff.
But I was thinking, so in some ways, I mean, obviously, I know you've literally got your code on like an EC2 instance and stuff, but if you were to keep that separate, so you had your code on a separate non-Amazon infrastructure and your database on Amazon infrastructure, RDS and all the rest, then if you kept your key, like your private key on the separate server instance where the code is, then I guess that in some ways is safer from having it on your Amazon if you didn't have two key.
So KMS is a service on Amazon, so you actually use that in conjunction with it, and like it's kind of opaque, really. You won't see it happening, really. Okay. I mean, one way you could get around it is that if you are, you want to use S3 for just object storage, and you don't want to, use any of the stuff in it, and you really want Amazon to be hidden completely from it, even if someone went in and got to these objects and were able to read them, that they really didn't understand anything, you could encrypt it at, the application level that you have when you put it in and take it out, encrypt it and decrypt it.
Yeah.
And kind of do it that way. So, you say your DigitalOcean box and stuff. But another thing, I know that you're a big fan of DigitalOcean, but one thing I did notice was Lightsail, which is their kind of competitor, which, kind of provides just that $5, kind of instances and all that kind of stuff. They are adding load balancers and also free SSL certificates, which auto-renew. So you could just have a load balancer, which then you just have. So you could, in theory, have the load balancer, have one instance just, kind of behind it, just so you could take advantage of like the SSL certificates for free. Kind of, I know that Let's Encrypt does it, but then you have to also obviously like, deal with the handling of renewing them. But it's just something that Amazon will just deal with for you.
Okay. And the second question I sort of had was, because I listened to you. This will surprise you, but
you listened to me.
Whoa, to you.
That is not good.
I know. I was listening to your podcast with Joe, which was really good. And, thanks to Joe for spending his spare time again doing a podcast with us. It's really good of him. But yeah, obviously you were talking about security in PHP. And that also got me thinking, and I'm sure this is probably open to debate, but if security was like your main sort of focus with an application you were creating, would that have an impact on the programming language you would use? And you'll probably say maybe 10 years ago or something, or I don't know what the answer to that question is, but do you have an answer to that?
That's a good question. I don't really know, because like there are like watertight languages like the ADAs of the world and stuff, aren't they, that are very kind of like they're for like mission critical things that people use and whatnot. And I suppose it's the language that you're going to do the least kind of mistakes in, like, but then that's hard as well. I couldn't say that. I would say, PHP, like adding libsobium and stuff like that, these are just great additions that as long as you're writing the code in a secure way, you're thinking of it at your level. Obviously, all languages and stuff are going to have some problems. Bugs exist everywhere. So, I wouldn't say, maybe you're using C, or then you're like, oh no, you have to use assembly. Oh no, you have to use Go or this. I would say, the language you pick really kind of has to be, do they deal with security bugs well? Have they got sufficient tooling around it, such as like, the integration of something like libsobium, which is, miles and miles better than like the mcrypts of the world, which are now, kind of defunct pretty much. So you can actually, deal with encryption and stuff in today's standards. And really kind of coding well, like in quotes, kind of safely. It's such a different way of thinking. Like I think that's where AWS has kind of helped a lot as well, where, and then going back to AWS, where it's kind of like, putting things such as like, encryption everywhere and all this kind of stuff has just helped, because it really does just kind of make it easier. If you're having to think about it all the time, that's the problem. Like you have to have people either in your company thinking about it all the time, or if you just kind of provide it as a service and it just kind of transparently happens. I did say actually, that, the encryption stuff with key management stores stuff was, key management systems was opaque and it kind of transparent. But actually, you can do things such as like encrypt certain bits of data and pass them as environment variables, which get decrypted and stuff. So you can store them in GitHub repositories or Git repositories and stuff.
Well, I guess the only thing, I mean, I could be completely wrong saying this, but PayPal, right, is predominantly written in PHP, the code behind PayPal.
Is it? That's pretty cool.
I might be completely lying there, but I seem to remember...
Facebook definitely is. Well, hack, but...
Yeah. So, but I remember being at a PHP conference and remember saying about the amount of currency that goes through software written in PHP. And, it was obviously billions. And they were saying, obviously, and people who make PHP make no money out of it. And I'm sure that PayPal got a mention. So, but I could be completely wrong and I'm going to get slaughtered for it. So it's the kind of thing I talk about it and then I research it after the podcast, which is the right time to research the material. So, yeah, I'll have a look and then apologize in the next podcast.
No, but I think that you say like there's two schools of thought. Do you want to trust Amazon at least? Like, can you trust Amazon more than you trust yourself? Where you kind of just kind of say, look, you're going to do a better job of dealing with this encryption than me. I'm going to put myself, because you can bring your own keys and stuff. That's one thing. Actually, there was in the keynote, there was Goldman Sachs talking about like they want obviously the encryption and to bring their own keys and stuff and everything and provide the keys, etc. Which may be something actually that you probably want to look into, with this kind of thing where they have a lot more control. There's also things like hardware encryption kind of things they can add in and stuff like that if you want to get some really technical. So I mean, all these big companies like banks and all this are using it. So there's obviously going to be, an element there that they obviously have their own security that they trust. They trust Amazon to an extent, but then obviously they obviously have their own internal teams and security teams that are doing a lot of the work. So I think Amazon have catered for that and have, every time, it seems to be that every time there's a problem that a customer has, Amazon will add a service or rethink about something. And I think that's one of the beautiful things about it. They constantly change. And as the name of the conference is, they constantly reinvent. It's insane, actually, how much they change, how much they kind of innovate over stuff, and they provide to us. Like this machine learning stuff is groundbreaking stuff. And there's like actually something like a deep lens, which is going to be a developer centric kind of hardware component video that you can experiment and do like kind of machine learning in hardware on and actually buy it. So next year you'll be able to buy this machine learning, camera and be able to do, incredible things such as what the guy was showing how he could put up a vinyl. So he'd put up a picture of an album art and do a sad face or a smiley face. And it would actually compute, what the album was, if he was happy or sad with it. And then eventually with, building up this kind of knowledge, he would then be able to generate a music library playlist based on the things he liked. And this is all stuff you can do. This is stuff that, you can train models yourself. And because it's cloud based, and this is one thing I'm realizing more and more with cloud is that you can just experiment so much more and really kind of try things out. And, you can go to the level you want, where if you really want the lowest levels, there's now like EC2 bare metal instances where you have the clouds, kind of philosophy around, start up, pay on demand, do what you want, etc. But you get to actually deal with the hardware at the base level where you actually get to, kind of integrate with the CPU, with the GPU and stuff, or you go up levels and levels and levels and you've got like the new container stuff, the new Kubernetes stuff and all this. And especially like with the machine learning where, they've given you SageMaker, which is this platform that allows you to kind of abstract away certain bits that you may not want to know about yet, or you may not need to, or you just, use the transcribes or the transcripts or the, all the Amazon like recognition stuff of the world, which just, brilliant stuff.
You're such an Amazon guy now. It's sickening. It really is. I mean,
you know what? This is the sad thing, though. I know this is the funny thing. Like, I have been putting it off for so long, and it's finally like opened the doors, being like, wow, there's so much stuff now. Like now, I think my builders we've moved over to Amazon stuff, and we've kind of heavily kind of invested our. Well, we're running on it now. So we really have invested a lot of our time into it and our infrastructures on it that, we can now take advantage of a lot of this stuff. And one thing, I had the week off last week, actually, and, with the keynote stuff going on, and I'm a sad guy. So, experimenting and stuff. And I was playing around with a couple of little Lambda bits and bobs, like serverless stuff. And we just released a blog post actually on the tech blog. I'll put it in the show notes, where I was experimenting with memes as a service. So it's a very simple, contrived, like kind of Lambda service where you provide, you have a selection of meme backgrounds that you normally choose, and then you can just generate the top and bottom text text elements of it. And, it uses things like image magic and stuff, and it just has it all in a Lambda. It's all, kind of, you pay for it as you use it. So you pay per meme kind of thing, and it's an interesting thing. And because that's the nice thing about thinking about Lambda. Lambda is only pretty much Dockerized containers of each of your functions on a base Amazon Linux operating system. So another thing actually I did was I used something called SOX, which is the Sound Exchange application. I compiled that down actually into I compiled that down to be compatible with the Lambda Amazon AMI.
Yeah.
Put that in, and I'm able to actually do something like joining up. So I did like, and the winner is. So it says, and the winner is, and you would actually use Polly, their like Google kind of voice thing, and it would actually, say, and the winner is. You pass in the name, and then you would return back an MP3 with it all joined together, and it had a little applause. So I've been experimenting with a lot of those sad things. There's another blog post coming out for that. But yeah, it's just great. There's a lot of services. There's a lot of way of integrating them all, things like that. There we're playing around with Lambda where, you've got function as a service. You're then experimenting with Polly, which is another service they provide. But you get to, just use it as and when you want. You don't have to worry about another API to an external service. You can just kind of deal with it in the Amazon world. And then you're dealing with compiled application code, static binaries that you've compiled yourself, and you're able to actually run them in these containers and in this Dockerized kind of instance, which is abstracted out into just little functions. So it's just a great way of thinking. The function as a service, to me, like serverless methodology paradigm, it really kind of feels right.
Yeah, I give it 1 year before you move on and move everything over to GoDaddy, because they have tools that everyone can use. 1 year.
Oh man, this is the thing though. With I think Amazon, over the last 5 years, they've completely changed a lot of the way we think about stuff, and that was one thing actually. So taking back, kind of going back to our previous episode where I said, my builder, we've moved all over our whole stack, and we're still kind of thinking in a server-based model. There's that analogy where you're dealing with it as pets or you're dealing with it as cattle. We're definitely still treating some of our servers as pets, where we're kind of nurturing them, we're slowly, patching them and whatnot. We're thinking about them kind of as individual assets as opposed to cattle where you consider them. It's not very nice analogy really, but you don't treat them as kind of, individual things, bless them. So I would say we're definitely thinking that. And there's other analogies like the snowflake to the Phoenix to the immutable server-based model. And this is what cloud actually allows you to kind of explore and open up to, where snowflakes are kind of how I definitely used to use servers back in the day, where, you'd have a server and you'd patch it, you'd install it all on the server. It would become this box where you don't really know what the configuration is because it's kind of occurred over time. It's just compounded over time where you've got these updates, these configs and stuff. And that's kind of, they call it a snowflake where, it's this very brittle kind of delicate thing you have to be very careful of. Then you move on to a Phoenix server architecture where Phoenix is like you burn it down like a phoenix and you rises from the ashes. So the idea is you can actually tear down the box and build it back up. So things using like Puppet and Chef and things like that, where you can actually orchestrate and, you can kind of provision boxes from a base and generate a server to the configuration you need at that time. And I would say, I wrote it in the blog post, actually, another blog post I did where I'll put that in the show notes, where, I think we're between those, where we're more on the Phoenix side because definitely we can provision these boxes and definitely moving on to EC2 where, we have to, we've definitely invested a lot more in kind of provisioning new boxes and stuff like that. We've got our tool chain down there with Puppet. But I really want to kind of get over to the side where we are moving to a more mutable server architecture, which is definitely how the cloud, you really can take what you can take advantage of in the cloud, where you just, everything's an image. And I like immutable, coding, like immutable functions, like the mutable paradigm, the functional paradigm and mutable paradigm don't change anything. And the idea is that you just build a new copy of it. So what would happen is that you'd have a deploy release, you'd have the stock image that you've provisioned with, as a Phoenix server. So you built that up and then you would pop on the code for that deploy and you'd create a new ARMI, a new AMI image or just an image based on whatever provider you're using. And you'd put that on the server. And then you tear down that whole server when you want a new version, or if you want to say update PHP to the new 7.11.12 or 7.1.12 or whatever, you'd provision a new server and you then have a new base AMI image that you would then have to deploy on, and everything would be images and everything is in itself in its entirety, where you would never SSH onto a box really. This is kind of what I feel. You'd never SSH onto a box and apply a change or an upgrade manually, or change a configuration file, do a deploy on a box where, you have multiple versions of it and you're just doing symlink switches and stuff. Everything is a different image and a different server, and you can tear them up and down as and when you want.
I feel like it's interesting because this whole idea of serverless architecture and the immutable server architecture type thing is definitely the way forward, but it also feels like in some ways that we'll be losing a bit of an art, because I guess for me, like after learning code, the next sort of step was like learning how to set up a LAMP stack and all the rest. And I think, speaking to most sort of programmers who were self-taught, that was a route that most of them went down, was code, and then I guess more a little bit of DevOps and that kind of thing. Whereas with this kind of infrastructure, you're going to need less of that. Doesn't mean that it's less skilled, because I just started looking at Lambdas and all the rest, and there's a learning curve there, and but it's different, isn't it? In my mind, I feel like developers of the next generation can be very different from ours. But again,
I think they're more specific, and I think where we've got when you think of yourself as a full stack developer, you have to have a host of different skills, and being an expert in one or being an expert in a couple, or kind of thing. But it's a tough one. Like I agree with you. It is nice to be able to kind of think about the whole stack, but the more I kind of go down this more DevOpsy kind of dealing with architecture, infrastructure route, I realized like if someone else can deal with it, it's a lot easier. Like patching boxes and stuff, it's just no fun and always a problem, and all that kind of stuff. And dealing with hardware, dealing with provisioning boxes, dealing with provisioning servers, hardware, real hardware, handling, real hardware, handling real servers, the levels up, where you got platform, where you got infrastructure as a service, platform as a service, where platforms allow and empower developers who don't want to know, but they want the safe skill, they want the safety, and they want the ability to do load balancing and expand and contract as they want.
Yeah,
they can deal with platforms, and they can deal with things like Beanstalk or Heroku and things. Or you get into the functions where it's like, I don't really care at all about anything but the language I'm using and what's the input and output, and that's it. So it's a really, different levels, but it kind of empowers each person at their level, because at each level they want to be at, where if you only want to deal with the code, you only have to deal with the code. If you want to drop down and you want to use things like containers and stuff and start building up applications that way, you can. Or if you want to deal with just actually dealing with the infrastructure and only having the abstraction level being that you don't care about the compute, you want, the operating system above. But you really, it is interesting where probably 5 years ago we were dealing with hardware. So we were dealing with not even having the abstraction of compute. We had to understand the computer, we had to understand the CPU, we had to understand everything about it from a fundamental level to build up. Whereas now you can kind of come in at any level you want and excel to the level you want to be at. But they all have their pros and cons, and there's some things that workflow don't work well with, say, a serverless architecture, or you have to kind of think of differently than when you can move down the stack and stuff. So it's very interesting. So you said you're looking into Lambdas and stuff. What did you think of them? I
literally just glanced really. So also I know you've used them, and I know my friend Nick is using them for his. So he created like a I don't know if I told you this, but like a five-a-side football like organizer thing. So he used it internally where he was working, and it was a huge success. Everyone loved it, and he'd really not. He's very much sort of Java world, but so this was like his first step into like using Amazon and all the rest, and he found it very easy to use. And I guess probably because you can write the lambdas in Java, and so he sort of started talking to me about it, and I really didn't understand the concept of it at all at first, and then had a little look, and I mean, to me it looks really cool, but I can't at this moment in time get my head around. Could you build a large application with just lambdas, and then how would you structure it in a way that was readable? So you've got like a JSON file, haven't you? That sort of determines what lambda to be used on what type of action. Is that the sort of idea?
So at a fundamental level, it's just a simple function you can kind of think of. Input in. You put some input in as an event, and output comes out, and you can either chain them together, or you can do a side effect or whatever. I think the one thing that wins out with something like AWS, or what wins out with the function as a service paradigm, is you have to have good inputs and good outputs. Like there's no point if you really have, you can do all this compute inside of it, but if you can't send it anywhere, if you can't get it in or you can't invoke it from anywhere, it's kind of a pointless thing. And that's one thing, Amazon's done very well with like API Gateway, with all of the different bindings you can get around. Like there's a lot of things. So another thing actually with reInvent was a lot of talk about the Internet of Things, small microcontrollers, or like those little dash button things and stuff, like the Amazon buttons and stuff, like very simple single purpose hardware modules. And now there's this Internet of Thing one-click service, which essentially binds, say, like, a hardware button or an action like that to a Lambda. And like these are things that make Lambda and empower Lambda, because these are the inputs and stuff that you want, the stimulus you want in, and then you can do an event out. And like outputs and stuff can be API gateway responses, can be things into databases, can be email, anything you can think of, it can do. But you do kind of have to think about how are you going to organize this? Like it's not a typical web application. You have to think of it in a bit of a different way. And there's things like the serverless framework, which allows you to treat things more as kind of, cohesive unit, where you've got a bunch of functions that kind of relate to each other and coexist, where it's like an application API and stuff like that. One thing I'm working at the moment is a very stupid like mince pie challenge API kind of thing, and what it does is it has like the ability to rate mince pies, add mince pies. It uses authorization through Cognito, which is the AWS user account management service, so essentially they deal with the sign up and the management, the passwords, everything of users, and I just get back the authorization and an UID which tells me that's that user, so I can let them deal with that. Yeah, the way you have to structure it, there's this model called the SAM model, which is the serverless application model and stuff, which I'll put some things in the show notes. I need to read up more about it myself actually, but I've been mainly dealing with, say, serverless stuff at the moment, serverless framework, where I've just been kind of playing around with more contrived examples. But when it gets to a sufficient size, and it is interesting that more and more people are actually building bigger and bigger things, so they're learning from this new design pattern and stuff, and it is a new design paradigm and way of thinking. But I just think the more I do, so the more I deal with servers and the more I'd have to deal with patching and all that, the more I don't want servers. It's actually funny. You just realize this is work that you don't really need to deal with. If someone else can deal with it for me, great. Like if I can just give you the code and you run it, and this, the pros are that you will patch the boxes, you will deal with scaling up and down. I will pay just when this code's run. I mean, that's in itself is just an amazing attribute to have. Like the fact that I don't have to pay for a server to be running all the time for someone maybe to hit this. I only know that I will pay for it if that function gets executed. Yeah. It's just a great way of thinking, and it completely changes the way you kind of can design and build things. And yeah, the way of scalability just goes, to kind of, it just, completely changes the way, the thought processes that you go through when just building and kind of planning out how you're going to build an application.
Yeah. Yeah, I'm kind of sold on it, to be honest with you. I'm going to have to look into the user management thing you were just talking about as well, because that sounds good.
Cognito, yeah. So there's two things actually. So there's the Cognito user pools. So user pools allow you to, so essentially there's like their own JavaScript SDKs and all these different SDKs for it, but they deal with the concept of having a user that needs a password, that needs verification. It deals with multi-factor authentication. It can deal with the time-based one-time passwords and things like that. All dealt for you. You don't have to handle it. You don't have to worry about hashing. You don't have to worry about any of that stuff. You just let them deal with it, and you have the user, and then you get a simple UUID back, which is that user. There's things also called federated pools or identity federated pools, and what they allow you to do is actually pull together multiple different user accounts. So say you may have ones that are hosted on Amazon, but you may also have ones that are hosted maybe locally to yourself.
Yeah.
Or, on your own servers, or you may want to have Facebook, or you may want to log in with Google. You want to log in with all these different types of user accounts, but you want to deal with it and actually access them in a kind of logical, federated way. It can deal with that too, and you can, handle it.
How does that work with, that's what you're saying, so you can, let the user fill in username and password, it goes off, and you just get a user ID back or GUID or whatever, and do you then have to create a session or a token, or does it give you that as well?
It gives you back a token, so it uses OAuth for that, OAuth too. The actual library, the SDK library, so I'm using it for a single page application actually for this MincePy thing. It handles it all for you. Like, it's great. So I'm only using the user pool part of it actually, and I can just call it to ask me to sign up the user, to register it, to confirm the user to log in. And when it logs in, it just provides me back a simple, it's JSON Web Token. And I can just supply that in all my requests to my API.
So you'd have some sort of like middleware that every time you need something that needs authority to do it, you would call Amazon and it would check that the token is still valid and does all the reissuing of the token.
It does all that. So that it might, what I'm thinking, So what I know of it is that it does do the refreshing on its own and everything within inside this SDK.
Right.
So every time I'm calling and asking for that token, it's always an up to date token. The actual third middleware actually at the client end, at the server end, is based on using Lambda, the API gateway authorizers, and you can just bind saying I want an authorizer, whether it be a custom one, so you can do your own custom stuff, or I'm saying just make sure it's part of this user pool. So as long as it's someone inside the user pool who's been confirmed, yes, they can access this resource, and then I can do stuff within my Lambda as and when I want. It's just a completely different way of thinking, and I understand. Like I am putting a lot of fish in one basket, or a lot of I don't know what the I am putting a lot of trust in Amazon there. Where you're kind of putting a lot of kind of all these services together, and you're kind of wired them up to solve your needs. But I think the pros it gives you definitely outweigh the cons, where I'm able to spin this up, and now I don't have to worry about pretty much anything. Like once it's running, it's running. Like the user stuff is managed by them. I don't have databases that I have to worry about. I can do a DynamoDB database, which is hosted by them. I don't have to upgrade. I don't have to worry about the server. All these things go away, especially if you're a one-man band or if you just want to try something out. This is a great model to try it on, and it can just expand and contract it how you want. So
the problem with having these conversations with you is I dread them because I've been working on an application in my spare time, which I'm now going to have to tear apart because I'm sold on definitely the management side of things. But and also, this has been worth it for the new manism, which is putting all your fish in one basket, which I would like to be the name of this episode.
I think it definitely will be putting all your fish in one basket, because no one wants to put all their fish in one basket.
You don't want to fish in a basket. No,
you don't. And actually, so speaking about the serverless architecture, so that it's pay for what you use, really.
Yeah.
They've actually, and this blows my mind. So Aurora is the Amazon's managed database. So they manage MySQL, they manage MariaDB, they manage Postgres, but they also manage they also have their own offering, which is Aurora, which it seems to just be amazing. Like it's compatible with MySQL and Postgres. There's a couple of little bits we've noticed in the Postgres one, which we really would like. But it essentially allows you to scale in infinitely in and out kind of thing. You can think of it as and when you want. But it also has now provided, so typically with a database, you would have to have it always on, and you'd provision a massive box for it. And, it'd be like, a massive box that would deal with all the traffic that you may get throughout the day. Well, now they've actually been able to separate the data tier from the compute tier, and you can actually you will be able to get serverless Aurora, which essentially means that you can scale and you only pay for the queries that are actually being run on your database.
That makes so much sense.
Which blows my mind.
Yeah.
It really does, but it's insane to think how, throughout the day, it's very active, and then through the night, it's not. And you don't get charged for it. You only get charged then for the data being stored in S3 or in whatever computer, like whatever data storage they use for Aurora.
Yeah.
It really makes you change the way you think about just everything. It's just, and this is what the cloud gives you. This is because they can do it at such a scale, they can give you these gains and they can produce these services that you would never even be able to dream about making. Like they're at such a different scale that they can produce these things and this tooling around it. They've actually purchased Cloud9 a couple of months back, and now they've released that as well. And Cloud9 is this online in the browser IDE, and it allows you to do stuff like, so you essentially be able to just develop in the browser as well.
So I guess I was going to say again, because I'm paranoid, but I mean the hackers are always going to focus on the things that are popular, right? So I mean, I guess in the back of my mind is always this fear, like you say, put all your fish in one basket. And then you wake up one morning like, Amazon's been hacked, and basically it's the end of the world. But I mean, I guess the chances are so small, but it takes a confident man to say would never, ever happen.
Exactly. And you know what? And this is, again, it's a calculated risk, isn't it? Where do you want to take advantage of all the tooling and kind of the way you can move and, duck and weave and, the common things like patching servers and stuff, like when a bug comes out, like I trust Amazon more than I would trust me having to, well, you know, you would have to patch them yourself, or you'd have to make sure that all these servers and all these different bits of infrastructure that you have to remember to patch them all to keep them up to date.
Yeah.
You know, I would say, you know, letting Amazon deal with that is a far better thing. And they're going to do a better job if they're going to have to, because they've got teams that are just solely, their job is just patching stuff.
Yeah.
So they're going to patch everything. Whereas I would have to do it as part of my job, where I'd have to remember to patch it, where I'm probably doing other things. So it really allows them, because they've got this scale, they have teams that deal with this. But I do understand, I agree, you know, like you are then putting all your fish in one basket. You know, you're saying if they get hacked, you're screwed. But I do then put that a lot of companies, bigger fish in the pond, you know, they have invested a lot more in AWS than we have, or than we would ever do. And they're reaping the rewards. So why can't we, if we're a smaller, are we worrying that much? Like, where's the value and where's like the perceived benefits, and do they outweigh the cons that could potentially happen? And I do believe that the pros outweigh the cons in this. And that was always our discussion point with moving to AWS was, can we trust the systems, and how do we go about, you know, kind of handling the fact if something bad happened? But you just have to kind of sometimes think, look, we're going to get so much value out of it that it's going to outweigh the con that could maybe potentially a percentage, you know, minor percentage happen.
Yeah. Also, in other news, I have it on good authority that Father Christmas has dispatched, or will be dispatching, my Raspberry Pi and sensor kit.
Oh, sir, this is exciting time.
I know. Well,
why don't you speak to the audience about our lovely WhatsApp discussion about this?
I can't remember what the discussion was. So,
you just sent us, didn't you, some like interesting things? Like, so what are you thinking about making with this Raspberry Pi?
I don't know, but I know, like, for example, like one of the sensors is like testing for like the like how much water is in soil and that kind of thing, which is going to be useful because I grow a hell of a lot of things, and so there's a lot of things that it's going to change my life. Put it that way. But no, I'm
looking forward to blog posts on this, man. I need blog posts.
I haven't done one in years. Yeah, that's interesting. Yeah, I probably will do it at some point. And again, but like you say, it's finding the time, but it's going to be limited to like when Toby's gone to sleep and stuff. But yeah, so no, I'm looking forward to it. I really am. And the book looks good. The downside is I'm going to have to learn Python, which isn't really a downside, but obviously I spent pretty much a whole podcast slanging it off. So that'll be good. But no, it'd be good to push me to learn a different language. So, you know, it kills two birds with one stone, really.
No, it's good, man. And because last episode you were talking about how you wanted to like kind of handle microcontrollers. You were kind of Elon Musk, dealing with hardware, dealing with electronic side of things, the actual automation mechanics behind stuff. This is a great entry into it.
Yeah, definitely. And I think long term, I've got a real interest in sort of batteries and storing electricity and how that all works. So I'd love to have a look at that at some point as well. I think that'd be my long term goal, and then maybe start trying to do things with sort of solar energy and then basically just take over the world. So
very cool, man.
Yeah, very
cool. Actually, I've got one thing. Actually, I know that we want to keep this short and sweet this episode. One thing I've been doing at work, actually, and this is again an AWS thing I'm always need to talk about at the moment, is AWS. So we're actually decided to pump all of our traffic through CloudFront. So CloudFront's their CDN offering, but they have the ability to deal with dynamic content through CloudFront. And so you may be asking, why would you bother dealing with, you know, dynamic stuff through CloudFront? Why not go directly to your server? Well, the benefits you get from dealing with CloudFront is you get their web application firewall. So they actually deal with, you know, DDoS attacks and things like that. You can use the AWS Shield if you want some real DDoS attack protection, but you get like a good, you know, sufficient enough kind of through their standard offering. And you get to deal with things like it deals with SQL injections, you know, simple cross-site scripting stuff. All this stuff kind of just, you know, the traffic comes in and they're able to just look after it and parse it a bit better like that. So they'll do a rate limiting as well. So making sure, you know, all these things I configured with Nginx, they'll be able to deal with rate limiting and handle all that. They also deal with SSL terminations. So you don't have to deal with stripping, you know, like SSL termination stuff, you know, TLS stripping and that whatnot, your end. And they can host the certificates their end as well. Another thing with the CloudFront benefits with the CloudFront stuff is that they have edge nodes, especially if you're doing global stuff, but particularly like, like kind of you can think of it in really anywhere. Like, they have edge nodes or edge locations in many places around the world. And also they have, they're called POPs, points of presence as well, where they have a lot of different servers hosted around the world. And what you can do is what happens is the request from that user will go to that POP or go to that edge location, and it will go through the Amazon's own infrastructure directly to your service. So they can pipe it through as like HTTP2 traffic. So it'll come, from, one HTTP1 from the client, go to a very close location, geographically located point of presence from Amazon, and then go through their pipes all the way up to wherever your EC2 instance or wherever your infrastructure or computer is actually based. So you just you get the benefits from that. You get the benefits from the SSL termination. You get the benefits from the web application firewall and the rate limiting and stuff. And it just allows you, again, to kind of remove some of that care. Like, I don't want to deal with termination of SSL. I want them to deal with it. I just want to deal with my compute and my logic and, my infrastructure internally. And it's just a great way of thinking.
You read my mind, because I literally was going to ask you about that. Actually, it was the kind of like the intrusion detection software and that kind of thing. So, yeah, that's really cool. But one of the other questions I was going to ask was, is it ever safe, like, to say, okay, only accept requests from this IP address, or can IP addresses be hoaxed in when a request comes through? Can someone say it's coming from this IP address, but it's not?
No, well, unless they can proxy it through that. So, yeah, you can say it's going for that IP address. You have to be careful, make sure it's a static IP address that doesn't change.
Yeah.
So the scary thing, obviously, with us is that, especially if we've got, home internet connections, you don't really get static IP addresses. Yeah. So you can do ranges, if you want to say like the Virgin Media range that you typically have, like, so you can just get the range of IP addresses. But yeah, so you can't, it's not possible unless you proxy through to get that IP address. You can't really trick the server into believing it is that. Without it actually being
okay, that's cool.
But again, it's putting all your fish in one basket, but it's saying, does Amazon deal with CloudFront and deal with like points of presence and deal with the fact of let them strip it and let them pipe it to my box and then I'll do it and return to you. And other things like there's Lambda at Edge, which is essentially Lambda, a reduced Lambda compute power function as a service at each edge node. So I can do very simple, stripping, cookie requests and stuff like compute and little functions at the edge nodes per request, instead of having to worry about it at my server.
So in terms of, say you go down the microservices infrastructure and you've got lots of services that communicate, how would you use Amazon infrastructure to authenticate, whether they're allowed to communicate with each other in the first place? What would be the best way?
So the way you do that is through things like VPC. So that's the virtual private cloud, and IMA roles. So that's identity access management roles and stuff. And they, Amazon, when you first go into the Amazon AWS stuff and you look into it, it can be quite scary. The amount of it's very complex in some, with the policies and the roles and stuff, because there's so much, around it. But you soon get there, to understand, kind of accessing the roles, allow and deny, and kind of restrictions and stuff. So you deal with it on a role-based basis on the AWS world. And then you use things like VPC to deal with and construct your own virtual private clouds, which is essentially, your own network infrastructure. So you want a subnet for this compute, this type of service. So you have your load balancer, which only interacts with this subnet, and that this subnet can only return traffic on port 80 or whatever and stuff. And you can have security groups which are actually per instance. So say like in EC2, you have a security groups that actually say what this service can actually accept and deny.
Right.
So what happens? This is the beautiful thing about say EC2, like with security groups, is that it's a whitelist as opposed to a blacklist. So it will only you specify exactly what ports are open, and it's stateful. So it means that it will, say a port 80, I get a request in from port 80, I can return from port 80 or port 22, but it doesn't open everything up by default. So it's a software firewall that they manage that allows you just to, add and rules as you please.
Well, I'm going to have to wrap it up. That was full on, but yeah, I'm sure we've got other stuff we can cover in the next.
I'm sure next time, man. No, it's been great, man. Do you want to do the closing salutations again?
Yeah.
The closing.
But I'm not going to say it's been the greatest. It's been the second greatest episode ever. So thanks for listening, and we'll be back at some point. Thanks for listening.
See you later, guys.
Cheers. Bye.
Bye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com. Or follow us on Twitter at the number 3 Devs and a Maybe.